All right, so that's the only thing we want to input here. All the rest, we're going to keep the default values. Feel free to read them if you need to learn more, but that's the main parameter. That's mostly what we have to select here. And then remember that we will also add a random state parameter to make sure that we have the same results displayed in our notebook. All right, so let's do this. Criterion equals, in quotes, entropy. Perfect. And then the second one, random state parameter that we set equal to 0. Great. And now, final step, you know exactly what to do. We take our classifier, and from this classifier we call the fit method to train our decision tree classifier on the training set that is composed as is expected by the fit method of x train and y train. Exactly the same as before. And now once again we're done very efficiently with this implementation. So I can't wait to see the results. I don't think we will beat the accuracy record, but let's see, we never know. So let's click this folder button here, and then, you know, right now it is connecting to a runtime to enable file browsing so that, you know, we can access your files on your machine. And in a second we should be able to get the upload button. There we go, as usual. So upload, and so that's the right data set. Let me show you the path again. That's the whole machinery A to Z folder. Please find it on your machine. And then we're going to go to part 3 classification, then decision tree classification, then Python, and then social network ads.csv. All right, let's press OK. And now here we go. We are ready to run all the cells by clicking this runtime button and then run all. All right, and now it is training decision tree classification model. Here we go, we have it now, you know, with all the default values of the parameters except criterion, which we set equal to entropy. Then what about that new result? Great, we got the right prediction. Remember that customer of age 30 and estimated salary $87,000 didn't buy in reality the SUV and was predicted not to buy it either. So perfect. Then when predicting the test set results, we indeed get a lot of good predictions, except some incorrect ones here, for example. And then, well, it looks actually pretty good. Maybe, you know, we will beat the accuracy. That's another one. All right, another one. And okay, let's see. Okay, because, you know, there's actually also, when you scroll up, some more prediction. But let's see. I'm very curious. Actually, maybe I spoke too fast. We're about to find out right now with the confusion matrix. Are you ready? The accuracy of the decision tree classification model is 91%. Wow. Okay, so it's actually in the podium, you know, right after KNN and kernel SVM, which got the best accuracy of 93%. Wow, so that's really good. Actually, this is really a good sign for Random Forest, because Random Forest is basically a team of decision trees making the predictions. And you know how team spirit always improves the results, so we might have a chance to beat the record accuracy with Random Forest. So that's pretty exciting. And now when visualizing the training set results, which we already got, you know, the execution was not too long. Let's see what it looks like. Wow, okay, so that's pretty different as before, and no wonder why it got pretty good accuracy. Because indeed it looks like it was able to catch, you know, the little observation points that were really hard to catch by either a straight line, you know, with linear classifiers, or a nice curve like with kernel SVM or naive Bayes. Here we actually splitted this whole grid into smaller subgrids, and that's because, you know, we have all these splits in the decision tree classification algorithm. So no wonder why we get all these subgrids, and therefore we get separate prediction regions. It's really interesting. That catches very well the observation points. So it catches all the red customers here who didn't buy in reality the SUV. It catches also all these green customers who bought in reality the SUV. And it catches, you know, these very hard to catch customers here by creating indeed these subgrids of the grid with the right prediction regions. So you see how it got that good accuracy? It really tried to catch everything, even for example these green points that were cut among all these red points, okay, these red customers. Okay, but that's, be careful, the training set, you know, on which the model was trained. Let's see what happens with the test set. And we already know that we will get good results because we already know that the accuracy on the test set is 90%, but still, let's see what we get with new observations on which the model wasn't trained. All right, so this is what we get, and actually here we see things more clearly. This is the prediction region, which funnily was a good fit for the training set, but here it is not catching anything, neither red customers or green customers. Here seem to be two incorrect predictions, because they fall in the green region. Then here, that's all good, that's all the customers of small age and small estimated salary, which therefore won't be likely to buy the SUV, as it is the case here. And then all these green points are correctly predicted. This one is incorrectly predicted. So indeed, we have our 10 incorrect predictions in all this. But there you go. If I didn't see the accuracy first, I would be afraid that we have some overfitting here. But no, it doesn't seem to be the case. Even with new observations of the test set, we get great predictions. But now what I really want to see is the final accuracy of our final classification model. Let's find out about this in the next practical activity. And until then, enjoy machine learning.